Hey, and welcome to the show. Today we have HashiCorp DevRel Power with Chris Williams and Rosemary on, and we're going to see a lot of cool stuff focused on Terraform. So, Rosemary, what are we going to see?
Well, we are going to do CI/CD for Terraform and more generally talk about CI/CD for infrastructure as code. And we're going to do it in the context of CodeCatalyst. So I think that the overall flow that you'll see is something you can package and put in some more generic CI framework if you wanted to. But the steps are going to be replicated in something more specific. We're going to talk a little bit about testing, and we're going to talk about deployment workflow as well.
Cool, and we're also going to see a custom blueprint that we can then use and open source for everyone else to use. So this is going to be kind of a best practice template for all of you to follow up later.
Yeah.
After the short intro, let's do a personal introduction as well. So, Rosemary, who are you? What the hell are you doing here?
I'm Rosemary Wong. I'm a developer advocate at HashiCorp and author of Infrastructure as Code Patterns and Practices. I have a passion for CI/CD, especially with infrastructure as code. I've done a lot of work in the DevOps space. I wore a lot of hats as an SRE, software developer, somehow somewhat semi part-time security person. I don't know how that happened. So because I've worn a lot of hats, I feel like CI/CD has been a really interesting space for me to be in because it has so many touch points to all of these interesting topics.
Yeah, and you're a perfect guest for my channel because it's all focused on CI/CD, and I have the same passion. And it's funny that even if it's a niche, I'm meeting a lot of people that have the same interests, right? So that's really great. And Chris is just here because he made the connection. So Chris, who are you?
I am simply the boring sidekick that brokers introductions. My name is Chris Williams. I am also a developer advocate at HashiCorp. I've been an enterprise architect in the cloud space and data center space for 20 years, and I am going to be asking the questions that folks want to know about for this little shindig.
Yeah, and you're also an Amazon AWS hero, a community hero, in the same way that I am a DevTools hero. I think that brings you and I together. We did a lot of things together already, so it's great that you take time to do this with us and to not waste your time. As you already said, you're going to be the one asking all of the smart questions because Rosemary and I collaborated on this, and we have some cool pieces of code available for you. So Chris, over to you, and I'm going to try to be quiet.
Well, you said I'll be asking smart questions. Let me clarify. I will be asking questions. Other folks will be able to determine whether or not they are smart or not. So do we want to have the walkthrough of the blueprint? Do we want to talk about CI/CD best practices? When you say over to you, you're throwing me to the wolves. What is it that we want to do? What's our process?
This
is your show.
I love putting people on the spot, Chris. You know that. So let's start. Rosemary, let's talk about Terraform CI/CD best practices. Is it just Terraform apply and you're done from your local machine?
The joke is, it's Terraform. You only live once. Terraform YOLO. No, it's not quite so simple. I think infrastructure changes in particular have have a lot of stigma around them. There's a lot of fear because you're highly automating a change that is going to some very important foundational systems, and so the stakes for pushing a failed change are very, very high. It's very challenging to recover a change at times if you don't have a good setup for infrastructure and infrastructure automation. So there's a big fear around pushing a change out, especially in infrastructure as code. So it's not quite as simple as saying, I'm going to Terraform apply and push those changes to cloud. Although people do that, and they do it successfully. So if you are doing that, I'm not going to judge you for pushing straight to production, because that means that you probably have a workflow that hopefully catches all of the problems that you might have in that process. But just as you want to quality gate certain parts of the software development process and the software deployment process, you do also want to put some quality gates around infrastructure and infrastructure as code. So if we start from the very beginning, it's not enough to say I'm going to develop Terraform locally. I'm going to write resource quotes and this AWS resource, and let's deploy it to AWS. When you do it locally, right, there are some things that you might want to think about from the very beginning. Is it formatted correctly? And this seems like a nitpicky thing, but if other people are going to read your code, and if you're going to continue to iterate on it, format your code. That's it. And so the same applies to Terraform. So locally, format your code. And then the second piece of this is, how do you know that you're writing it properly? What are some rules, general ground rules that you should be thinking about? I don't know. Do either of you know how to create an S3 bucket, a private S3 bucket off the top of your head? Like all of the right ACLs and attributes for it. Yeah. See, no one knows. No one understands how to do it from their memory. So having some kind of linting rules or general rules that you're going to have in place for as you write infrastructure as code is really helpful to narrow the initial feedback cycle. Because if you think about it, the earlier someone knows how to do something correctly, the faster it is to deploy to production. So having some kind of linting rules in place in the very beginning also helps facilitate infrastructure as code from local to production. And then that's just when you sort of get to the more official CI/CD process for it, right? From a best practices standpoint, you'll want to think about linting formatting, and then you'll think about planning. Terraform Plan is a dry run. It shows you the basics of what might happen when you apply that change. You can use testing, what is, I guess, called unit testing in infrastructure as code space to understand if those changes are what you expect. And unit testing and testing in general in infrastructure as code could be its own recording entirely. We're not going to go far into it, but you need to run tests against the plan because the plan often has the most accurate, up-to-date dry run of all of the things that you need to do. So we're going to show this a little bit, but I do want to provide a conceptual overview of all these pieces. So once we get past the plan, we do some unit testing, and then after that, you can decide to apply. And apply is a little bit challenging. Inevitably, in infrastructure, you're going to have multiple environments. You're going to go from non-prod to prod. I very rarely see people deploy straight to prod in infrastructure as code. So you first apply in a non-prod environment, do some integration testing, do some end-to-end testing, and then you can promote to your production environment. And the same process applies. Once again, unit testing and plan, unit test, apply, integration test, end-to-end test. So that's the general rule of thumb when you're thinking about infrastructure as code CI/CD. You can also add a lot more steps.
Let's hold on just 30 seconds.
It's a lot.
You just said something that caught my interest.
Yes.
Someone that I have worked with before, Søren from TerraMate, has recently asked on LinkedIn a question around how do you do your Terraform best deployments? Do you do merge apply or apply merge?
Yeah.
Now, you just said we do test and we do plan, we do test. Do we do then merge or do we then do apply? What's what you're advocating?
Yeah. So feature branching, right? I think we had a quick discussion on this. Some folks decide to do feature branching. Some folks decide to do environment branching, and that sort of dictates a merge, right? That's where it's a little bit strange. So let's assume that we're talking about the feature branch approach, not environment branching. If you're environment branching, I can tell you that it ends up having some really weird issues with it, so just avoid doing it. But when we talk about environment branching, that means a branch for prod, a branch for QA, a branch for dev or something. It just causes all sorts of issues. So just avoid environment branching in general, especially in the context of Terraform. But if we think about feature branching, right? Feature branching means that if I wanted to, let's say, add a security group, right? If I wanted to add a security group, I'll create a feature branch, add that security group. What I find is that it is better. It actually is very, very, very appropriate to merge and then apply. And the reason being is that you're not going to catch everything on a plan. That's the reality. You're not going to catch everything on a plan, but most folks from a cost saving standpoint, as well as a local testing standpoint, do not have the resources to apply in isolation. This is really important. When you do a feature branch, while Terraform handles locking and handles all of these things for you and handles sequential application of changes, the problem is that you might be creating a security group that overlaps with someone else's security group rule change, right? And that kind of conflict, if you apply before merge, gets lost in context, right? Then you're in Slack and you're like, hey, did you accidentally apply on your branch? and then everybody starts crying because you don't know whose changes went where. And so the result is that in order to preserve a more consistent deployment of changes to infrastructure as code in particular, at least in my opinion, it's typically better to plan, merge, and then apply in a lower environment. And the reason being is that the sequence of changes will then apply and cascade into a higher environment like production. Oftentimes, if you get out of order in these changes and you then promote them to production, that out of order sort of causes an inconsistency or some kind of drift in the way these changes are being applied to production, which causes then more potential for failure. So people will do and apply before merge, and sometimes this is by creating a whole new environment on their own, but it's very expensive, and I don't find too many people successfully doing that while managing the cost of so many different environments.
And I think there is also more to think of as well, right? So you need to think of how do you manage state files in the case that you do that. And then you need to make sure that you can rename resources or have them kind of with the environment name in it and these kind of things, right? There's a lot of potential to create friction, right? Yeah. But what you're advocating for requires us to be kind of doing something like trunk-based development in a sense, right?
Yeah.
And that's not all organizations are able to do that today,
no.
right? So I think that's a point that we also need to consider.
Yes.
So why is there, let's say, you're a great advocate for CI/CD. Why does it feel like everyone is still doing Terraform CI/CD different than everyone else? So why is there so much confusion around what the best practices are as it looks like?
I think it's because it's organic. A lot of people don't actually think about CI/CD in the very beginning with Terraform, and it's very organic in their adoption, right? So if you think about even infrastructure as code adoption in general, you read about it, you write some configuration, and then you just apply it locally. And you're okay with that. As a team, you might be okay with that for years. There are a lot of people that I know who still do things locally and who still apply changes without a CI/CD process with infrastructure because they get a lot of value from the very beginning and they don't see a real reason to add it into CI/CD, into a CI/CD framework and put a pipeline around it. But unfortunately, as you grow your Terraform usage and more people adopt it, it becomes really challenging to just apply everything locally. And it's no longer sufficient to just use a plan. If you're in a regulated industry, or even forget if you're not even in a regulated industry, if you're in an organization that has a lot of changes going into infrastructure and has a lot of expectations around security and sort of best practices around default configuration, it becomes really challenging to do everything sort of haphazard and with this organic hodgepodge of Terraform configuration. So I think that the reason why there's a lot of variability is that we try to migrate or backport CI/CD practices into our more organic growth of how we adopted infrastructure as code. Then we just sort of say, okay, it's good enough in this middle period of time. We don't have testing, but we do at least have a plan, and we apply and we put it in a pipeline somewhere. And that's sort of good enough for now. It's hard to invest in testing after the fact. It's hard to invest in a broad change around how you apply Terraform after you've already started using it for a couple of years.
Yeah, and I think that's one of the things that we should try to change going forward, like giving people at hand the possibility to start with the ICD built into the project that they kind of start off or scaffold, right? And I hope that at the end of the call we have something as well to share to show that people can maybe directly use as well.
Yeah, exactly.
With that, I would propose we have already wasted 14 minutes without code, so let's jump into code, right? I always try to talk about level 300, level 400, very detailed stuff. Yeah. Let's look at the project that you have built and then see how we can move that over to custom blueprints.
Sounds good. So this is an example project that I put together. The Terraform itself isn't as interesting. It creates an S3 bucket and things like that. But I think there are some important things embedded in the Terraform configuration that we'll go through in the context of CI/CD. So in terms of the outcome, this is going to deploy an S3 bucket to an AWS account.
I'm going to try to ask a dumb question.
Yeah.
did you just get started with this project, or did there something that how did we start our journey on making this available? What was the first things we needed to do?
Yeah, we'll back up for a second. So a couple of the first things that we needed to do was that we created a CodeCatalyst space for this, as well as a project, so that we could collaborate on it. One of the things that you do need to set up is Bootstrap. Bootstrap refers to any of the initial resources you need in order to run Terraform. In the case of Terraform in CodeCatalyst, we are using a community action or Terraform Community Edition action, and it requires an S3 bucket for storing Terraform state, and it also needs a DynamoDB table for locking. When you apply changes to Terraform, there is a locking mechanism that sequentially applies those changes and ensures that no one's going to overwrite the current state if a change is in progress. So you do need a DynamoDB table to lock those changes as they are being applied. So this Bootstrap actually has its own pipeline that deploys a DynamoDB table and an S3 bucket, where we can get down into the details about Bootstrap, but at the end of the day, it sets up sufficient resources for other projects, Terraform projects, to store state.
Yeah, and I wanted to show that because that's one of the reasons that I never liked to start with Terraform, right? You always needed to think about how do you set things up for then being able to share it with each other, right? And now with the Bootstrap project that we have here, it's going to be, well, it is easier at the end, right? Mm-hmm. Because you can just execute the workflow, you get your environment set up, and most probably you're only going to be using that Bootstrap project and workflow once in the whole project, right? Yep. But still, it takes away some stuff that you usually need to, I don't know, copy paste manually, right?
Yeah, exactly. And I would say Bootstrap, there's a debate around whether or not you should use, if Bootstrap should be in its own CI/CD pipeline, or it should be it can be run locally. I would say that you should probably share state for Bootstrap somewhere, even if it's some file that you've decided to commit and secure somehow. But you do want to make sure that you are treating your Bootstrap code in a way that you can collaborate with someone else. So do remote state for it. That way that if you do need to go back and reproduce it, for example, you have the ability to do that. Otherwise, you will find yourself creating a bunch of new resources every time you run the Bootstrap.
Yep. Cool. Yep. So now let's go back into the example project that we have.
Example project. So let's start with the workflow. I'll just let's do the deploy workflow rather than the branch workflow for now. So this is the main. This isn't on main or trunk. So the first couple steps here is to basically run against a lower environment. So we're using the environments out of CodeCatalyst. We've already set this up, but it's going to connect to non-prod. And the first few things that it's going to do is, of course, format. This is something that you can run in your pipeline. And what it will do is that it will format your code. It will check that, and it will do it recursively across many different directories. This is extremely useful if you have submodules in Terraform in the same repository. So this is the correct command. If you do want to do that, what it will do is stop the pipeline the minute it detects a format issue. Is that a little bit, I mean, I guess it might be a bit strict, I would say. But if you do want to make sure that as you collaborate across Terraform, you're formatting it correctly across your team, it's a very rapid fail at the very beginning of your deployment. We're also using a community tool called tflint. Tflint is a linter that is going to go through your Terraform and provide some suggestions on some best practices. So in the case of my Terraform, for example, I have an S3 bucket, and I was loading some files into the S3 bucket. One of the things that it was complaining about, if I can find it somewhere. One of the things that it was complaining about was actually that in Terraform, you should use square brackets, for example, and not just use the dot notation for array indexing. And so it was telling me, hey, you should be using square brackets and not dot indexing for arrays in Terraform. And so it tells me some best practices around how to write it. It is a community tool. You can add your own custom rules if you do want to, but it does have rules out of the box that you can run and check verify that your Terraform is conforming to some best practices there. Again, it's a fail fast kind of command in the very beginning.
A CodeCatalyst question on that, and I'm not sure if we actually checked that. Terraform will most probably also generate some reports, right? Are we able to see those in CodeCatalyst? I was just trying to check myself. I think not, right? Maybe that's also something that we could look at later.
Yeah.
To then connect the reports that are generated by TF-Lint at the end and visualize them in the quality reports components of CodeCatalyst.
Exactly. So it doesn't generate. I would say it generates an output which we can funnel into a report somewhere. That's not in this workflow here, but if you have custom linters or you have your own, some people write their own. The idea is that you would be able to take some of that output and put it into a report. Okay.
Cool.
Yep. So let's go into the main part of this, which is we are using the Terraform Community Edition action. So this is going to be available in CodeCatalyst. It does require a DynamoDB table as well as a state bucket and the state key. So this is going to allow Terraform to store the state in an S3 bucket as well as lock based on that DynamoDB table. I recommend put your state in non-prod or any lower environment in a different bucket than in production. Don't share state buckets because, there is sensitive information in Terraform state, and you probably don't want to be distributing the state of non-prod with the same access as the state of production. So that's.
And while we are on that topic, if you scroll up a little bit, line number 45, we have a role.
Yes, we do have a role. Also very important. From a security standpoint, you don't want Terraform to deploy to have admin access to everything. You can, but I would also just warn against it. While it might be easy because then you don't have to add new API access to other AWS offerings. It is better just to lock down what that role has access to from an AWS standpoint. So this role,
and I love that you're saying that because you just got a new task right after this recording. The Bootstrap project, we should enhance that to include the relevant roles and with the relevant permissions somehow. I think that's something we didn't do yet, right? No. So if we have that Bootstrap, we could also use that to bring up the roles, which we're now going to be using as part of the deployment.
Exactly.
And it would be cool if we could add that as well later on.
Yeah, so Bootstrap, we can just do S3, right? Rather than say, have access to everything, we only need access to S3, so we'll create an IAM role that has only access to S3.
Yeah. But the Bootstrap project can also create the roles that we're now going to use as part of this deployment. So what's your take on, obviously, we should use different roles for production and non-production.
Yes.
What's your take on one account, multiple accounts?
One account versus multiple accounts. So is this one Terraform to orchestrate across many different accounts? One Terraform role. Yeah, you could. So it does happen.
I don't know.
Yeah, so it does happen. But what I would say is that you would control that by role assumption. So if you do need Terraform to orchestrate across multiple accounts, this is fairly common. Let's say if you have an account that's localized to database that's only specific to database functions. You have an account that's specific to some EC2 belonging to some business unit. Very common. Terraform has this ability to specify do something called provider aliasing. So you can say, this provider goes to this account, this provider goes to this account. Use that to pass the role that you want to assume in each account, right? And so then you would have the Terraform itself has the ability to assume role into these accounts, but itself does not have cross-account access. In the same way.
Yeah, I think in the CodeCatalyst example that we have over here, we would be able to specify different roles for the different steps in the deployment, right? Yeah. And I think that would be then the possibility to do that without using the Terraform aliases there, right? Might be a possibility, but we need to try that out.
Yeah. I would say if you're bringing in existing Terraform, you might already be using aliasing, and in that case, if you have a role that has sufficient permission, a role for CodeCatalyst to sufficiently assume role into these other accounts, and it's in the alias, then you probably are okay. But if you're starting net new, it might be better just to add the specific roles here. Mm-hmm.
Okay. Yeah. So as Chris is here, can we bring up a little bit more kind of let's bring up the diagram for the workflow. Maybe that's something that is not as much code as we have, right? I think that should also give us the visualization a little bit easier.
I was just about to ask to drill down into that, like what does this look like, and where are the accounts, and how, Thank you, Johannes.
So there's only one account, and it is creating an S3 bucket. And so as part of this non-prod, really the action is going to do a plan and then apply. I don't know how to panel width. There we go.
That's interesting. Yeah. You can also make it very big on the right-hand side. It's funny because since CodeCatalyst was released, I've been struggling with exactly this. It's been more than 18 months. So I really hope that this changes soon.
Yeah. So what the action itself does a few things, and it's not necessarily well visualized here, but it is creating an S3 bucket in an AWS account. The account, the role is being defined, and then it's using the workload identity in order to be able to create that S3 bucket. So it's a standard Terraform workflow of init. You'll notice that there's some init commands here. It will pass in the bucket as well as the DynamoDB table. And then it will download plugins. This is part of the init command. It will download provider plugins, in this case, AWS. And it will then validate. This is not something that you have to put in your pipeline in the explicit lint or format step that we have here. Instead, the action itself takes care of the validate. Validate doesn't always tell you everything that's happening, even from a dry run standpoint. So, but it does give you enough information about whether or not you have the correct syntax, whether or not there's something that's not resolved in one of the resources. And then it runs a Terraform apply. It's interesting because the action itself doesn't apply pretty immediately. There is no, at least in CodeCatalyst that I could find, there was no manual approval yet. So you kind of have to just jump immediately into an auto approve. And so you're probably wondering, hey, Rosemary, why is this auto approving and why are you not worried? Part of this is that there is a way that you can do testing in Terraform, and this is where unit testing might be appropriate. If you are doing some kind of Terraform plan in CodeCatalyst, and then you do some outside unit testing, and then you do an apply, it would gate this process. So you can say in this workflow, you can say Terraform apply only and not auto approve, and then the plan you can then test it. That's something that you have to do outside of that action, of the action itself. But what we've done here is just use what we have. And the reason why this is important is that that way you don't have to add any other new libraries in place. There is testing that you're allowed to do in Terraform, and it makes it a lot easier. The testing that I've implemented is what is called a post condition. You can think of a post condition as a unit test. A post condition runs after a plan. So the reason why you don't see an explicit plan in CodeCatalyst is because these post conditions will already flag problems right after a plan. And that's what's really important about using doing what's out of the box from testing. In terms of the life cycle, it's already built in. So a post condition will check for certain attributes after a plan has run in Terraform. And you don't have to put it into a separate testing library. So the post condition will stop. So if, for example, the bucket has more than one ownership control rule, then the plan will stop. It will say, there's an error. I'm going to throw an error for that. We can try it. I don't know if we can try it live or not, but given time. But there's also some other conditions that you can check as well. There are a lot of post conditions that I've added for each resource, for a number of resources, not every resource, but a number of resources. Again, testing isn't we're not aiming for 100% test coverage necessarily. What is 100% test coverage in infrastructure as code anyway, and what is test coverage? But what you're trying to do is find some important parts of the deployment that might be a problem, whether it be from a security standpoint, a configuration standpoint, or a functional standpoint. Things that you know to be true that you probably don't. You don't want to go put immediately in production. And so, for example, ACL private.
Maybe just just a question on this, because you said like this is infrastructure unit testing at the end, right? This does obviously not replace application unit testing, and it might also not replace integration testing that you want to run if there is more than just infrastructure deployed as part of this Terraform apply, right?
Yeah, exactly. This is not going to be coverage across everything. So if you do need to do, let's say, testing of your application, it's not like traditional unit testing either from a software development perspective. It does require, unfortunately, infrastructure as code unit testing does require access to the cloud API. It's very hard to mock a cloud API, which is why you probably have to do this plan anyway, or you have to do some kind of dry run. So a lot of these tests you can build into Terraform, and it will stop it after the plan. So if, like, for example, if I said I'm going to change my bucket ACL to public, then you can probably see that fail. Probably should have staged that. So that's the built-in test, and that means that you're going to do an implicit plan, and then implicit plan upon this apply. So that's what you see here.
And this deploy workflow, we talked about that earlier, just reminding ourselves, will be executed on the main branch only, right?
Yes, this one will only be on the main branch. There is a workflow that is for the feature branch. So if there is a branch that you want to implement changes on, it will run that. And so there are a couple other pieces here. You'll notice that it does the apply, and it has some outputs. But there's also this interesting resource action that's being sort of flagged here. This is data. You'll notice this says data as the objects example we read during. So this is actually called a check block. This is the output of a check block, and this is what you would consider a built-in integration test. The important thing about the built-in integration testing in Terraform is that you write a check, and the check verifies whether or not certain HTTP endpoints are up, or whether or not there's certain conditions that are being met. So in this case, I am using the data S3 objects data source from Terraform to call the S3 bucket and check what objects are in it. And I expect 2 objects in it, should contain 2 files, and I want to make sure that the keys, anything in the bucket, matches what I've created in Terraform. And so this is what you would say is an integration test or end-to-end test. I would say this is probably more on the integration side. If you were to do something like an end-to-end test, you might say I'll create a EC2 instance, and maybe I'll curl to I'll use the HTTP data source in Terraform to request the application that's running on the EC2 instance and verify that it's up and running. So there are a number of ways that you can check for attributes or check for endpoints as part of an integration or end-to-end test in Terraform. A check block just makes it easier to verify this after the fact. So it will run after the apply. If it's not successful, it will flag a warning that tells you that the check has failed, and that is an indication to you that you have to verify if maybe the resource didn't create correctly. You can also check the status of various resources. So if you're doing VPC peering and you want to make sure that it's actually active, then you can also use a data source for the peering connection to check the status. One thing to note, check blocks are non-blocking. So you do have to parse the output of the check in order to verify and fail your pipeline appropriately.
Okay, so that would be something that we would need to implement somehow in CodeCatalyst or in any other CI/CD tool that we use, right?
Exactly.
Cool. And another thing I would love to see, and I know it's not there, would be a visualization of the check results at the end, right? Also in form of a report or something like that, and then making that somehow also available, right? Another thing on this deployment, if we go back to the deployment execution, what I find difficult with Terraform is I never know what infrastructure has now been deployed by Terraform. I always need to search, right? That reading that plan is something reading that output is something I don't really like. Is there an idea on how to make that, more visible, right? In this case, it's easy because it's just one or two objects, but sometimes it's more resource.
Yeah. So there's not really a way to decrease the verbosity of what is coming out of Terraform. There are ways that you can script out certain attributes that you're looking for and things like that. But despite the best efforts to figure out if there's a way to condense the verbosity of it, a lot of folks want the full report from an audit standpoint. They want to know which resources are potentially being changed as well as the attributes, and they want it attribute by attribute. But in terms of reviewing it, there are ways that you can parse out some of this information. Some folks decide to suppress the information, actually, and they use a combination of parsing the schema, the plan schema that comes out of Terraform, and the list of changes that comes out there to select which ones are most important to them. So that's one way that you can do it. And I think there might be something in Terraform CLI that allows you to sort of redact a few things out of it, but for the most part, it will by default just have verbosity on the resources that are under change.
Yeah. One of the things that I've always been talking about when using Terraform is that I never know the current state of my environment. Obviously, I have the state file that I can kind of look at. It can be very painful. Is there something that you can see coming that would visualize kind of the drift that I have or something like that in a simple way?
So for the drift between Terraform and the active environment, right? Yeah.
Yes.
Yeah, so there's not an easy way to visualize that. There is something in Terraform Cloud that allows you to do it. It's called drift detection in Terraform Cloud that allows you to do it. And it actually has the ability for you to check continuously whether or not there's a drift between your Terraform and the active environment. Most of the drift that you're going to see gets captured. If you do a Terraform plan, you'll find that there's usually like a little sort of a flag noting that something has been changed upstream and isn't in Terraform itself. That's hard to do if you have a lot of resources, but one way that you can check is, again, to verify that the changed resources are something that's noted upstream, that's an upstream change, and then it's going to be a little bit different than what you have in your code. So this is pretty common, I would say, in some resources that have default variables, right? And certain default variables get changed upstream in AWS, but those defaults aren't reflected in Terraform. And one way that you can automatically sort of just make sure that you bring that drift back in is to do a Terraform plan with refresh only. Refresh only means that it takes the attributes upstream and then it merges it into state, so that way you don't have that drift in Terraform anymore. But then, if you are actively trying to debug something that is in your Terraform apply that is being changed versus what is upstream, it is a little bit more selective because you don't always want to merge upstream changes to attributes into Terraform plan all the time. So if someone decides to test a security group and then changes it to 000, you might not want to merge that back into your Terraform. You might want your Terraform to override that break glass change.
Yeah, makes sense. So feature requests give me a possibility to visualize my state file easily somehow, right? And and that in the community version of Terraform.
Yeah, in the community version of Terraform. There are ways to visualize your state file by resources. So if you check out Rover, it's a community tool, for example, that visualizes it really well, but it won't necessarily visualize the changes.
Yeah, so ideally, feature request for the CodeCatalyst team. If I kind of use the Terraform community action and I don't have a possibility right now to see the deployed resources out of the Terraform, if you use the CDK deploy or the CloudFormation deploy action that CodeCatalyst has, you get a little tab where you actually also see the resources that have been deployed by this execution, right? And that's what I would love to get for Terraform as well, right? Because that kind of resolves that problem a little bit.
I didn't know they had that. Cool. That's nice.
that's why I'm the CodeCatalyst expert and you're the Terraform expert, and this brings this together, right? So it's great. Now, next thing after non-production would be production, where we would once again just execute Terraform apply with a different state file and with a different environment name, right?
That's correct. Yep. So the same process is duplicated in production. There are some folks who do like to have a separate process in production because there's additional requirements, for example, security testing, things like that. Those are things you could also include separately. They're very tool specific, which is why it's not in this workflow. Oftentimes, security tooling and scanning security static analysis of Terraform is done on production configuration. But the point of this is that it's going to duplicate the same thing except in production. I am also aware that not everybody deploys non-prod and prod the same. There are resources that folks will separate into non-prod and prod. We are taking the approach that we are ideally trying to mimic non-prod and prod as closely as possible. So we're using variable files to change the attributes between production and non-production. But if you are using subdirectories for, let's say, non-prod, and you're using a subdirectory for prod, and you're separating them out because you expect significant differences between the two, you might find you have different tests. You might find you have a little bit of a different integration testing approach, but the same process will apply. The same process goes. You do want to do a plan, unit test, apply, integration test, end-to-end test.
Yay!
Yeah.
And now we're on production.
And now we're in production. There you go.
But we just directly jumped into the deploy step. We did not talk about what we would run on a feature branch.
Yeah.
So recapping what we did at the beginning, the assumption of this project is that we're going to use feature branching. This means developers take the source code, create a feature branch, work on that feature branch. Then they do a push, then they create a pull request, and then they merge to main before we actually apply stuff.
Yeah.
For that, we also have a workflow here on the feature branch, right?
Yes,
so
we do.
What does this one do, and how does this help us to be better?
Yeah. So it's the same approach. I don't know if I can actually show this one, but this one is the same approach. It has the same exact steps, very much repeating the same steps. Format lint, right? You get to do that before it goes to production and before it gets merged. The main difference, though, is that it is going to trigger on pull request. So that's the main difference. And the other big difference is that it's going to do a Terraform operation mode plan. It's easier to show it over here, but in the action, in the community agent action for CodeCatalyst for Terraform, the Terraform operation mode is where you specify the specific operation mode. So the apply means the auto approve. That's where you see in our workflow, that's where the apply happened. But in this case, we want to do a plan because we don't want to apply these changes on a feature branch. Again, if we have lots of feature branches, there are a lot of conflicts that might happen. While Terraform can handle the sequential application of all these changes, we want to make sure that we are structuring these changes before they go into a lower environment. So we have the operation mode plan. And in this case, it is actually using the same state buckets. It's because we do need the actual state of the infrastructure before we apply it. And so what it will do is it will do a plan and verify unit tests, and then it will also do the same for production. Now, why do plan on non-prod and production? It's important just to identify both the changes to both environments before you decide to do a merge, because again, some folks do separate resources in production and non-production. And the result is that if there are different resources for the two, your testing is going to be a little bit different, and your dry run is going to be different. So that's why when it comes to testing changes on a branch, you do want to run plan on both non-prod, any lower environment, and the higher environment as well, just to be on the safe side, especially if your changes are going to disparate environments.
Cool. And now we're done. Oh,
We're done on this side, but we had the more important stuff, which is the blueprint.
yeah. So how does this collaboration started? Maybe we can talk about that as well, Chris. Tell me now.
So the way that this got started was you found out that I was now working at HashiCorp, and you said, hey, I want to do a collaboration with somebody smart over at HashiCorp. And so I said, great, that's totally not me. We should get Rosemary involved. Then you and I had a wonderful conversation with her about your channel and all of the wonderful things that we're doing at HashiCorp and all the questions that you had. And so I decided to connect you two and then basically get out of the way. How this came to be.
Took out vacation 2 weeks and left us alone with all of the work, right? That's the reason.
That was my favorite part of this collab, was me on vacation.
I can imagine. So at the end, what did I want to do, right? So I've told you, and most of my audience will also know that there's since reInvent 2023, there's custom blueprints in CodeCatalyst. So I said, let's use that to build up something like a best practice blueprint that we can use for bringing up Terraform projects, because it has always been a pain for me, right? And that's what we did. And our approach here was, and this is how I think you should be building blueprints as well going forward. You build the project in the way that it should look like, and then you try to abstract as much as possible. In this case, the collab was Rosemary building the project, and then I trying to make a blueprint out of that. And I would love to show that part of the blueprint. And there's a few things that we could potentially not add as well. But there's some changes to what I did, to what you have, Rosemary. I'm gonna show that because I think you haven't seen that. Not going to go into details on how blueprints are built overall, assuming that everyone knows that. And if not, there's a lot of stuff on that on my channel. And now I'm going to show, hopefully, if I manage to find my Visual Studio Code, the right one. And I think I'm going to fail. I'm going to share my screen and let's see how we get this out of the way. Okay. So you should be hopefully seeing my screen.
There we go.
So
yeah, we can see your screen.
I created a new blueprint in our heroes space. Within that, I have one source code repository, and I'm going to talk about that in the next few minutes. In the source code repository, which we're now going to see in Visual Studio Code, I have down here something that is called the blueprint.ts. And the blueprint.ts is essentially the description of how the project is going to look like that we're going to use. In order to replicate what we have just seen from Rosemary, there is a few inputs that we need to get, and I've added a non-production environment that users will need to use if they use this blueprint, and I have a production environment so they can actually choose. I've also given the users the option to decide whether they want to have that bootstrap project, yes or no. So the idea is really, with only one click, you're gonna get everything that you need to get started with using this CI/CD best practice combined with Terraform and actually executing that. Before we look into the code, I'd love to just show that to you and see if it actually works. So I've published this blueprint already, and I think that we should be able to create a new project out of that blueprint with the given version that I have already today. So let's get on create project, space blueprints, and as you can see, I've been playing around a little bit, and here we have the Terraform default project that I can now choose. Now there's some information on it, maybe not as good as it should be, right, if we make this open source, but I can now create a new Terraform project in recording, and this gives me the possibility to now select a target non-production account. I can select this one. I can select the role. As you can see, this is not set up properly, so let's stick to the one that actually works. Also, then now for the production environment, I could select an environment and a role. So this would then make my project already pre-configured to actually use this. And then I will tick this, do you want to create a new Terraform Bootstrap project as well? Because the moment that I now click create project over here, what CodeCatalyst is going to do, it's going to execute the TypeScript code in the background, and it's going to create the project structure for me. Ideally, afterwards, I would be ready to go and ready to deploy stuff to production. And this is, at least for me, it takes away a lot of hurdles in working with Terraform because I don't need to think about that anymore. And I'm ready to go directly after the projects have been set up. Thank you, Demo God. It seems to work. At least some stuff is there, right?
Look at that.
We have 2 source code repositories, as we've seen. We have a Bootstrap project and we have a Terraform project repository. That's the same stuff that you actually had before. Let's look at the Bootstrap project first. So here we have workflow and then the corresponding files that you already had with the same README and the same setup and the details that we actually need to get started. We have also the project that is the Terraform project, which comes with the example files, the providers, the main definitions, and once again also workflows. And I think that is pretty cool, right? Because it took us less than a minute to bring this up and running.
Out of curiosity, what's the devfile.yaml?
Oh, interesting question. This devfile.yaml can be used to open this repository up in a so-called dev environment going forward, which is a visual IDE, which is an IDE at the end that comes within CodeCatalyst.
Oh, nice.
So the dev file defines on how that actually works.
Nice.
There's some stuff that is missing that we would need to add, but first let's have a look on how this blueprint is actually built, right? So as you can see, it starts with this blueprint class, and then over here, I'm initiating this first repository, which is actually the Terraform project repository. I've given it a hard-coded title for now. We could potentially change that. Then here I can actually copy static assets. That's what I'm doing here, right? So I'm copying the static assets from the project code directory where I actually just copy-pasted the project that you had. Simple way. We could make this even better. In the example that I have prepared down here, we have the possibility to do something like substituting. In this idea, I could now substitute specific parts of the project with specific other parts. I didn't want to do that for this part of the presentation, but it would be cool, I think, going forward if we could have a blueprint that really 100% also changes the README for me, changes all of the state file names and all of that kind of stuff for me as well.
Yeah. So you can template, basically. You can use a template of those static assets and then generate.
Yes.
Okay. Nice.
Yes. You can do whatever you want with that. There's even more than blueprints can do, right?
Yeah.
But you can really use this as an input and then modify all kind of source code and modify everything that you want to have as part of your project.
Nice.
I'm creating environments. I can potentially also create 5 or 10 or whatever, right? So potentially now, if I decide I need to have a second production environment, I don't know why, but it could happen, right? And I have 10 projects using this blueprint. Now, if I just add this again and I update the blueprint that is used to the newest version, I will get this new environment automatically updated and added. I will also get all of the workflows updated automatically as well. Creating the workflow in this case is creating 2 workflows. So I create the test workflow and the deploy workflow. Here I can also use the same stuff that you had. I did one change. I also added the pull request trigger for the pull request in draft. I think you had it only for open and for revision, I believe.
Yeah.
And I wanted to have it also executed the moment that you create the project with the pull request, which I added draft over here.
Nice.
Other than that, all of the variables that we had are there. One thing that we would now need to also kind of make selectionable going forward would be the region. We chose US West 1 for now, right? Also maybe the state key table, the state key and the table I would like to have as an input variable. A lot of possibilities on how to make this blueprint even better, right? But I think it's a great starting point for looking at this. And then we have in the test workflow now the production version, right? Also, this is not good code. We could make this way better, right? But I think the story is the most important piece over here.
Okay.
For the deploy workflow, we do the same stuff. So we also have renamed things a little bit. We have linting here, then we have apply prod and on-prod, and then we have apply production in the same way that we also had that for the testing piece. And I guess that's it, what the blueprint at the end is about, right? So one thing that I was thinking of that we could also do, and it was just released a few days ago, is the possibility to also create issues. So now I can use blueprints to create tasks for individuals that start working on this project. So ideally now, after setting this up, I would now need to execute the Bootstrap workflow. I would need to maybe make sure that the state file is set up correctly. I would need to modify the roles and availabilities and stuff like that, right? But I can do this and all of this already kind of directly in the code, which will then actually be executed. because I haven't done that for a while, I would propose let's try to do one change to one of these workflows, and then let's look at how this would look from an lifecycle management perspective. And I would propose that we just we add an additional testing step, maybe directly after the deployment to non-prod, right? We would have an integration test or something like that added.
Mm-hmm.
So let's try that. And I would want to add a build action over here.
Yeah.
No, the build action, and I'm not going to implement that, but I'm going to
You could do a curl. I think a curl is a curl to some endpoint. You can use an arbitrary endpoint, but a curl is pretty representative of a common enough end-to-end test from an infrastructure standpoint. Maybe you just want to make sure that an application is still up and running even after you make the infrastructure change.
That's definitely a great idea. So I could now do this piece. Now, obviously, I need to change the dependencies, right? We have some dependencies set up over here. Somewhere it says depends on apply non-prod. In this case, this now changes to be depends on integration test non-prod. And for the action up here, actually, there is no depends on for this one. So we're going to need to add that. Depends on, and then they apply non-prod, and then I need a comma. So let's see now. What did I do wrong? What did I do wrong? Action name.
It's like build action doesn't seem to have depends on.
Looks like it. Let's have a look. Oh.
Lowercase. Yeah. Oh.
Interesting. Dear CodeCatalyst team, please make that unified. I know the root cause for that. Parts of the actions are generated automatically and parts of the actions are handwritten in the SDK. So this is where this comes from. But great that we found that. So now let's see. Git status. Now git add src. Git commit. I need to hide this. Git. Come on. Git commit minus. Update add integration test, and I'm gonna push that, and hopefully my single sign-on is set up. Okay, that is what usually happens.
I'd like to point out the fact that I am so glad that y'all have literally the exact same issues that I run into, because whenever this happens to me, I think like I'm just too new to this and I stink at it, and you guys are doing it too, so this makes me feel so much better about myself.
I'm going to make sure that this gets into the recording, Chris.
I have no idea why that changed. Same, bro, same.
Yeah, that happens. Come on. That's why we are developers, and that's why we cannot replace ourselves with Gen AI, you know?
Mm-hmm.
So now I fixed that. I fixed that thing. Now I'm able to push. What happens right after this push is now that a workflow is going to be executed in this project. So let's have a look on this. Now we are in the Terraform blueprint project that we have in CodeCatalyst, and we have a release workflow that is going to be executed. This release workflow is going to be automatically now creating a new version for the blueprint, which we can then actually refer in our project to upgrade that. That's pretty neat. One thing that I'm planning to do here is blueprints are npm packages, so I can update this workflow to publish my npm package to npm, which then gives Rosemary, Chris, the possibility to use this blueprint and to refer to this blueprint as well going forward, right? And that's going to be pretty fun, because then I can actually share my blueprint with you. You can incorporate that within your CodeCatalyst space, and you can then use the blueprint that we built here and apply it for all of the projects that you create in CodeCatalyst. That's going to be really cool. There's a lot of things that are still clunky, but I hope that this gets more visibility as well soon. So if we now go into this workflow, we're going to see that this is going to take like 2 or 3 minutes. But what I then want to do is I want to be able to upgrade this blueprint to a new version. So let's go back to, we created this Terraform. Where did we create that? We created this new Terraform project just a few minutes ago. And here we can see in the blueprints that today we are referring to the current version, which is 0.2. Now, I just did a change, right? I would like to update this to a newer version. So somehow I need to bring this new version of the blueprint into into the CodeCatalyst space. And for that, I'm going to go into the settings of the space. And in here, I will see that there is already a 0.3 version, but it's from 3 days ago. So we actually need to wait for the 0.4, which is going to be automatically created. And then we can apply all of the changes to our project. And you could potentially do that for hundreds of projects kind of at the same time in a semi-automated way. And I think this is where the power of blueprints will then actually come into play. So let's wait until this completes.
While we wait for this to build, I'm curious if there's a way to specify order of operations for different workflows in the blueprint, right? So in this case, we are creating a Bootstrap project, optional, but Bootstrap, and then we're creating the Terraform project. Is there a way for us to say, we're run the Bootstrap project first, and then take the outputs of that and use it as part of the the state bucket and the DynamoDB table? Because those are hard-coded right now, and maybe we have certain requirements or expectations on what those names will be, but can we do it more dynamically if, let's say, we ran the Bootstrap project, got those outputs, and then put them into the next workflow?
That's a great point. Today it's not possible, right? But what we could do would be we could, within this blueprint TS over here, we could obviously now also do all of the preliminary work, right? So we could now interact with the AWS SDK and bring up DynamoDB. We could bring up an S3 bucket. Then we would not even need the Terraforms that we added, right? Because then we could just do that as part of the blueprint creation. Yeah. This has good and bad parts of it, right? Because then you cannot change that afterwards. So that's why I referred from doing that. But today there is no possibility to interact between different projects and different workflows in CodeCatalyst.
Got it.
Okay, let's see. We should have, hopefully, a new version already. Not yet. No, but that's a great question. So I think do you think that would be helpful for blueprints?
I think so. I mean, I think that if you have dependencies across workflows, which is common enough, now I think if someone were to create the blueprint, they're not going to know the order of operations to run certain workflows if there's certain dependencies. I mean, the likelihood that you would have a lot of workflows, independent of each other is probably unlikely. But I think that if you've gone this far to automate the creation and templatize some of these files and some of these workflows, then it's a really helpful thing to have some kind of order of operations. Otherwise, the first time someone runs the project workflow for Terraform, it would fail because the action can't find the bucket and can't find the DynamoDB table.
Right.
Yeah, makes sense. How do you today bootstrap your Terraform projects? You just copy paste an existing project, or how do you do that?
Yeah, so usually it's you bootstrap. You basically copy whatever resources you have. And then you run it first, and then you have to run your workflow, the second workflow that uses that state after that, right? So it's still very manual. And the way that people do it from a community standpoint tends to be their own wrapper automation that runs, they have their own CI/CD, like larger CI/CD flow for Bootstrap, where it implicitly runs the Bootstrap and then everything else related to Terraform. And that's part of what is called like a landing zone. So when they build up a landing zone in AWS, they'll create the bucket, they'll create the DynamoDB table, and then run that. And then everything after that, including the CI/CD framework, just sort of never touches it, has all those attributes, and then manually run any pipelines that are running on top of the landing zone. So it's still very two separate, disparate manual processes right now.
Okay, makes sense. So we're done with the version. I can now update this to the version 0.4, which we have just created. The moment that I did that, I will now go back to our Terraform project that we created out of that. When I reload that, I will see that there is now a new current version. And I will be able to update this to the new current version by clicking change to catalog version. And the cool thing is here that before I apply this new version, I will now see the code differences that I'm going to get, right? Which is pretty fascinating because I will see what I'm taking in. I don't know why it takes that long. Must be my internet connectivity today. But hopefully we will only have a change in the workflow now, right? We will only have this new step being added. As you can see, we now have this integration test non-prod, and we have this change in the dependency, which is what we implemented. And I could now directly take this in, apply update, and my code will be not changed directly, but there will be a pull request that I can now review and get approved, which I think is fascinating. And this is if I scale this up over like 10,000 of repositories or hundreds of repositories, I think it will save me a lot of time if I'm able to kind of find the details. Kind of have something standardized over here, right? So we see that pending pull request, which I now need to approve to make this part of my main branch. Cool. And with that, at least I have finished what I thought I wanted to cover today. So this is first time ever that I failed to recover a recording of something that I did. So I'm back again with Chris and Rosemary to record the wrap-up of our session around Terraform blueprints. And this is exciting. As I said, it never happened before. So we're going to jump directly into it. Rosemary, what did you learn when we built this blueprint together for CodeCatalyst?
I learned a lot about CodeCatalyst, and it was really interesting to find all of the features and everything that was built in. It just made it really easy to get started and get everything sort of structured the way you would standardize on CI/CD pipelines. I was particularly interested in the fact that you could deploy new versions of blueprints. So just as much as you treat your deployment, your software deployment as with pipelines, right, and you do it as code and you do this versioning, you're also doing it to your own pipelines and your own workflows and those blueprints as well. So I was particularly impressed by that. I'll probably use that sometime going forward with CodeCatalyst as well.
Cool. Sounds like well invested time for you then. Chris, what about you?
So I have to say, this was the presentation where Rosemary finally broke me. It was so good. I have given up IT. I have purchased a farm. I have purchased horses. And I am now in a farming community in Lower Tennessee, drinking a coffee and giving up on tech. No, seriously.
Just before we go into the real world, Chris, can I use this and steal your hero title and give it to someone else? Because if yeah, okay, cool.
Yeah, I mean, if I'm not going to be in tech anymore, we might as well give it to somebody else.
Okay, Rosemary, here you are.
Oh, absolutely, yeah.
No. I don't need that kind of title. No. Just send me a pony. I just want like the horse or the pony from the farm, like.
I just bought those things. I'm not going to give up one of
them.
Okay,
we'll wait till the first fall.
I do have a squirrel.
Oh.
And I do have an elk. So I don't know what's better, right? And I do have a unicorn as well somewhere over here.
Is that better than a pony, Rosemary?
I mean, the unicorn is clearly far superior.
This one.
Oh, that's an interesting unicorn.
Oh, it's from the game days. Those are awesome.
Yeah. Anyway, Chris, so back to real world. What did you learn?
I learned, so anytime I'm with Rosemary, I always furiously take notes because she says things and I'm like, oh, I need to dig into that. So best practices around bootstrapping projects, check out TF-Lint, Bootstrap to create roles for CC deploys, multiple providers for multiple roles and multiple accounts, tons of different things. And of course, Johannes, the stuff that you showed, versioning, pushing out different blueprints. I learned so much that I have given up, and now I'm a farmer.
Okay, on my side, I've learned a lot about how to do Terraform CI/CD in the right way. I've kind of been using that for myself. I've also learned a lot of the built-in stuff into the Terraform CLI, which I wasn't aware of. So the checks, the verifications that we talked about, that was pretty good for me. I also learned that if you want to build blueprints, if you have already something that is there as a project and you make a blueprint out of a project, that is way easier than just starting from scratch. And I think that's where this collaboration was pretty fun, with Rosemary giving in all of the best practices and the knowledge around how to build this. and then me taking that over and making a blueprint out of it. And this could be something that enterprises could adapt as well when they build custom blueprints themselves. So that's, that was my takeaway. And anything else to add, Chris, from your side before?
I had a wonderful time. I am fully into the farmer lifestyle now. I've learned how to feed and care for cattle. No, this was fantastic. Like I said, anytime that I'm with you and Rosemary, I learn an absolute ton. So thank you for the time here.
Rosemary, not everyone knows you yet. How can we change that? Where can people find more about you?
You can find me on many of the social media platforms under Jack of All Trades, Master of None 08. So JOATMON08. And you can find a whole list of works and various things that I do on JOTMON08.github.io. So you'll find me on that personal page as well.
Cool. And I hope that I can add that to the show notes. And then actually, I hope that a lot of custom blueprints will follow coming from the HashiCorp side there, right? That you can also contribute to the open source projects that exists today, right? Maybe we can even bring this blueprint into that open source repo. Let's see. Thank you so much, both of you, for not only being my guests, but doing this re-recording with Ponnies in the background. That is great. It was a lot of fun. And looking forward to see this air in a few days or weeks from now.
Awesome. Thanks. Time to go feed the chickens.
Bye-bye.